So what we have is that, so they're talking about this furniture workshop, right? So they have the 5 carpenters, right? So they they are having that they and they are preparing 5 different types of furniture, right? So that they have exactly 5 carpenters and then 5 different types of furniture, right? So and then like each one is kind of like having a different productivity level, right? So that means like so if you give the carpenter one, then he can make 6 chairs per day, right? And if you give him the tables, he can make 9 tables per day, and so on. And so that's depending on the different carpenters, you can see they are preparing different amount of the items uh, the per day. So then you can see that like they are kind of like specialized in one, and then 1 or 2 areas, and then they not in the other areas or something like that, right? So so we have that information, and then uh, the profit they can make by the selling one item, right? So in terms of the 3 items, sorry, 5 items we have there, right? So by selling each one of them, you can make a profit of 3, 4, 2, 5, and 6. So that's the profits you are getting, right? So then now your target is to uh, the in terms of that carpenters, so now you have to give them like each one the task of like preparing. Of course you have chance of like giving them like preparing half of each as well, and so that like say their maximum capacity is 6, so you can say 3 here and then 5 here, something like that, right? You can give different capacities like that. But initially, now we are thinking about like giving for one person only one item, and so you can initially look at it like that. So and then you can see that now we can take some options like this. Now for an example, I can say that giving first carpenter chairs and second one tables and so on. And if you think about that, then that is if you're looking at the diagonal values here, right? So that's kind of like so you can see what is the profit we can make from there. So that's kind of like the 6 times 3, and then 8 times 4, and then 4 times 2, 10 times 5, and 10 times 6. So that's the profit you can make, right? So like that, now we have to look at that the all the profits we can make. So that's one combination, right? So like that, there can be like the several combinations we can identify, right? So there are like the plenty of combinations you can find out. So by checking one by one, right, it is difficult to decide on that the whether that the that particular option is suitable or not, right? So that there can be like several combinations. We have to write down all the possibilities there, right? But without doing that, we can think of like going for a the different approach here. So that's the we can write down our linear program here, and we can optimize the situation. So then now the in terms of like each assignment the given to each one, right? So then we can say now in terms of the profits we can make, right? So we want to identify the profits we can make. So if you give the carpenter one preparing chairs, then you can make a profit of 3 times 6, right? And then if you give the carpenter two uh, the chance of making the chairs, then you take a profit of 7 times 3. So you can see that like we can get those profits, right? So now using this table here, we can calculate those profits. So first we will try to calculate those profits, right? So let me calculate that one. So in this data set here, so there is the question number 4 here. So we have this information here. right? So with this information, right? So what I'm going to do is I'm going to prepare the profits. So let's calculate the profits. So I will create that table, and then I just want to calculate these cells here, right? So I need to calculate them again. So this is going to be equal to the 6 multiplied by 3, right? And then I need to fix that 3, right? So, and then I can pull it down, right? So now I can fix that 3 there, right? By pressing the F4, right? So there I think I need to fix the uh, only the column, right? So therefore uh, I can keep that. Oh no, so I need to fix the 8 there, right? So that later on I can drag it down to the other side, right? So then I can fix it by putting the dollar sign for the 8. So therefore that 8 will be there, right? So V8 will be there together, right? So therefore these are the profits I can make, right? And then I can do that for entire one, right? So then this is going to be C8 and D8 and so on, and so that will change, right? So you can see the everything, so all these are multiplied by their corresponding unit profits, right? So this is the total profits we can make. Now we can think of like now our target is to optimize the situation, right? So then if you're thinking about the optimizing the situation, right? So now previously we discussed about that we preparing that integer variables and then like the real number variables as well. And then I think I may discuss about one example that we can have in terms of the binary variables, right? So we can go with that the help of the binary variables. So now in terms of these cells here, right? So now the what we want to identify is that in terms of these profits, right? So whether we are using that amount or not. So that is the binary variable that we can define, right? So I can define a binary variable here, right? So if I define a binary variable, so I can define something like xij, right? So 1 and 0, right? So then I can say that the xij is representing that ij cell, right? So the profit value of the ij cell used, right? And 0 otherwise. So I can define that the xij value. So that means like I is moving from number of rows, say 1, 2, 3, 4, and 5, and j goes from 1, 2, 3, 4, and 5. So these are the numbers I and j can take. And so altogether I have the 25 variables there, right? So that's in terms of that representing all the 25 cells, right? So that the binary variable, that's the one we can define here. And so based on that binary variable, then we can think of the preparing the our linear program, right? So based on these binary variables, so now I can define here a set of those xij values, right? So I will label it as the Xij values here. So there are a bunch of Xij values. So I will so I can make that binary variables here. So these are the cells that I can change, and so Xij values that I can change. So these are the binary values that I need to identify. Okay, so so based on that, then I can define my objective function. So my objective function will become so it's basically so let me write it down here. So in terms of my objective function, so what I want to make sure is that I need to decide whether I use all these numbers here. So that means each of these number multiplied by the Xij values, right? And then I can take their summation, right? So my objective function will become, I can take the summation. So adding that is Xij's multiplied by the coefficients Ij, right? So I goes from 1 to 5 and J goes from 1 to 5, right? So that's the multiplication of each one. So that is 18 times x11, 36 times x12, and so on. So we can keep on multiplying them like that, right? So then I can use that in here as the sum product of these values multiplied by these values there. So that's my objective function there. And then I have some sort of constraints, right? So what are the constraints I need? So initially, my constraints are going to be so in terms of that, the each of these values. Now, if I say that like I need to use all these and then I'm doing maximization here, right? So I want to maximize the profit, right? So I want to maximize the profit here, right? So then what it says is that basically I can use all these numbers, right? But it doesn't make sense, right? So if I give the carpenter one to make chairs, then I should not give these. And so in terms of a row, I can see that only one of them should be one, right? And the others has to be zero,
Can I
right?
interrupt, sir?
Yeah.
Sir, could you please show the objective formula once again,
Yeah,
if you don't
sure.
mind?
Yeah, this one. Yeah.
No, sir, in the Excel.
Okay. In here, right? So this one, yeah.
Yeah.
The sum product, right? Sum of the products. Okay.
Can you please double click on that, sir?
Yeah.
All
Okay.
right.
So that is the sum of the products. So you can see that here as well, right? So you can define like two cells there, right? And then take the summation. You can take two rows and then define that as the sum of the products, right? Or you can define it as a matrix as well, right? So that's taking the sum of the products of entire values there, right? So that's the same thing as the what we have here. Okay. Right. So so that is the function we can use there to create the objective function. right? And then now we can think of like going for the our constraints here. Sorry. So now in terms of the constraints, now what we can notice is that if you take a particular row here, then like for the carpenter one, you're giving only the chairs to make, right? So then you can say this is one and others are zero. Or if you're giving only tables, then this is one and others are zero. So then you can see for a row, definitely only one of them will be one, right? And then the others will be zero, right? So we can notice that the in terms of the rows, right? The, the one of the constraints we can have is the I'll write down it in here, the row summations, right? So row summation has to be equal to the one, right? So you can define it as the row summations in terms of the each row summation has to be one, right? So that's I can define from here, right? So that's in terms of these variables, the row summation has to be equal to one, right? So I can define that constraint here by taking the just the summation, right, of this row, right? So that has to be, I can use equal sign here, right? And then the uh, equal to one, right? So I can put the one there, right? So that is for the first row. I can do that for the all the rows, and all 5 rows, right? I can do the summation and I can say that is equal to one. Right? So that's the one of the constraints, like 5 constraints that we can take from the particular condition here, right? And then same condition we can apply for the columns as well. So in terms of a column, then like for chairs, now you can decide that we are giving only for the carpenter one, right? So then this is one and then others are zero, right? Or if you decide to give for the carpenter 2, then this is 1 and others are 0, right? So therefore, in terms of a column also, only one of them will be 1 and others are 0, right? So then therefore, the column sum has to be equal to 1 as well, right? So therefore, I can define another constraint there based on the column summation, right? So I can write down the summation of the column and I can say that is equal to 1. So then I can do that for the 5 times. And here that I have to write down the okay. So I can define that summation of each column has to be 1 as well as the summation of the each row has to be equal to 1, right? So that's the condition we need, right? So therefore, like in terms of each row and column, we are definitely selecting only one of them. Right. So that's why I can say that like you can take the diagonal, right? So that's one option we have. But we can have that like several other options as well, right? So without going with the diagonal, right? So there are plenty of other options we can try. So we need to see that out of all these options, which will be what's the maximum value here. So that's the situation in terms of that our the defining this linear program here. So that's like the how we can design our constraints, right? And the objective function. And now we can identify what we can get from the our Excel solver, right? So I can go into the data and then solver here, right? So that's the package you can use there. So then I can see that the my objective function, that is the cell here, right? So first one, set the objective. So that is the objective function here, right? And I can decide to that in the maximization or minimization, right? So it is maximization. And then by changing the variable cells, so the variable cells are these. So that's what we are changing, right? So just I'm asking that software to put them on some of the one to each of them, right? And then check it whether it is satisfying these conditions, right? So then I have to define what are the constraints. And so I can add the constraints here. So once you add in the constraints, the okay, right? So I can define that so I can take this set here, right? And then I can put the equal sign here and this one here. So that's one set of constraints I can add here. And the second set of constraints, I can add this set here and put the equal sign. And this one here. So let me add that one as well. So I just add those the two constraints there, so it will appear in that box, right? And then finally I need to add one more thing here. I can select all these cells here, right? So I just have to select that the variable cells that I'm changing, right? And then in here I have to mention them, they are binary. That is the 1, 0 values, right? So they are binary. Okay, so that's my last constraint I need to add there. So I can say okay for that. So now I'm getting this output here, right? So you can see that my two constraints are there, and then the binary informing that they are binary. And then just I need to do, I don't have anything to do here other than that. So I can just say solve here. Right, so I don't know why this is taking too long. This Excel file is not working. So let's wait a couple of seconds. Right? So I can just write down it over here then, right? So until it appears. So I have these, that's my objective function, and then subject to the constraints, right? So my constraints are so row summation equal to 1, and then column summation equal to 1, right? So then by applying these the two constraints there, then so they're like the altogether 10 constraints are there, right? So then finally I mentioned them, they are binary as well. With that, then I can get the solution. So something went wrong itself. Yeah, my Excel is not working. So anyway, like until this is running, I can show you that like now we can go into this one here, right? So that's how we can get the solution. Now you will see that like once we get the solution, you get some ones and zeros here, right? So we have the answer there, right? So so we have to wait until this is running on here. So usually it is not taking that much time, but uh, maybe since I'm using that sharing here, so I don't know why it is taking that long. The, so you should be able, like in your computers, you already have the answers, I think, right? So I don't have the answer right now still. So I cannot go to the any other one as well, right? So let's anyway, like now the in terms of these the techniques now other than this one, so this is involving that binary variables, right? And other than that, we discussed some other questions there, right? So basically, like you have some constraints, they are based on the some maximizing of the production lines and so on, right? So some questions like that. So you can practice on some of those, right? So I will give you similar one like that, right? So like what we discuss at the class, right? So so you have this the Excel file there, right? So this one here, right? So we discuss similar type of questions there, right? So you can practice on them. So so until this Excel this is sorting out, uh, give me a second, getting called. Okay, so still this is not working.
Sir,
Yeah.
so if you don't mind, could you please show me that window you from where did you get it? We missed some parts. The
Uh,
window.
yeah, that still that this Excel is not working. That's why uh, I have to maybe close everything and start again. So give me a second. I'll close all this and start again. So I will
Okay,
stop the
thank.
sharing and start again. So
All right, sir. Thank you.
okay, right,
Okay.
right. So Okay. So now I just opened the Excel file since I have three of them earlier. So that may be the reason. So I will try this again now. So we can go to the data and then solver here, right? So we will do it again. So in solver here, so I had to first set the objective. So that is this value here that we put as the sum product, and so that is the value there, right? So objective value, and then this is maximization. And by changing the variables, these variables we have here, right? So I can select those two, right? The objective value, this one, and then changing the variables here. And then I need to add the constraints here. So for the constraints, I can go for that here, right? So then I can select so now I can select one by one and add the constraints, but since I have all these have the equal sign here, so I can just add all these together. And so I can select that entire column here, right? And then I have the equal sign here, and I can select the entire column over there. So that's how I can add the one constraint. And then the second set of constraints, I can add it in here and say equal here. And then these are the other cells here, right? So I can add those two columns like that. And finally, I had to select these cells here, right? And then say that in here they are binary, BIN, right? So that's binary. So that's my last constraint. So I can say I can say okay now. So since that is my last constraint, so once I say okay, so I'm getting that the equations here, right? So these three equations are there as the constraints. So uh, so that's how we can set up this the value there. And so just if I repeat it again, so set the objective function there, and then the changing the variables, selecting these, right? And then I can add the constraints, this set of constraints and equal sign, and then the right hand side, and then the set of constraints and equal sign and the right hand side, right? And finally, selecting my variables here and say they are binary. Okay. So once you set up this one, and I can say solve here. So then you can see that like answer is getting quickly, right? So we'll say that okay here, and you can see the answer there. So what does it indicate? So the maximum profit I can get is 177, right? And then that is the allocation is that. So the carpenter one given the tables, and carpenter two is chairs, and carpenter three the wardrobes, and then carpenter four beds, and then carpenter five shelf, right? So that's the setup we can have. So then you can see adding these the corresponding numbers according to the values there, right? So that's the optimum setup. So if you go for any other pattern there, then it's below this number. That is what we are saying. And that is, you're getting optimum value here means that. So if you go for any other pattern there, then you're getting below number below than below this number, right? So that's the guarantees we can have. So that's how we can set up this the linear program. And in general, of course, we have that other examples as well, right? So there you can see the in terms of uh, the allocations, the like the other examples. If I open that file here, so we discuss about some examples here. So actually, this last one is similar to that one, right? So this one, the another example, we discuss how we can identify the objective function and then constraints, right? So, and this is another example similar to that one we discuss. So setting up the objective function and then the constraints. So, so we work on up to this one here, right? So then, and we work on this one as well, right? So that's we did question five questions there, right? So I will ask you like say test you on something similar to this or like what we have here, right? So the nothing else other than those, right? So just any of those types, right? So I will test you on them, right? So so there you just have to think about that, setting up the objective function value and then the constraints according to that. So always you can go for the solver, right? So all these examples, you can go to the solver and they apply the objective function and the constraints. You can find out them on each one. You can see. So okay, I think like the what you have is the one we did last, right? So that is for the last one, right? So for each one, you have to set up it according to that. So the, by selecting that the variable cells that you are looking at, and then the by selecting the other values according to that, right? So the so that's how we can set up it, right? For the linear programming or the optimization problem, right? So now let's look at the other one, other example that we discussed there. The that is the question number 5 there, right? So that is coming from the simulations concept, right? So I will discuss about that one as well. So in terms of the simulations, so now we have this the example there. So we have, let's look at the example here, right? So they are looking at that large supermarket area, right? So they're talking about the customers arriving to make payments, right? So uh, the cashier counter has the can serve for 4 customers, right? The also that is the can serve. They have only one the cashier counter, right? And then they can serve the 4 customers per minute, right? So they are the cashier counters. The rate is the serving 4 customers per minute, right? So so then like once they observe the 1 hour, right? The number of arrivals, right? The and their observed frequencies, right? We can identify in this the table given here, right? So then of course now based on this the table here, right, we can develop the probability distribution and then cumulative probability distribution, right? So eventually like we need these cumulative probabilities, right? So we'll open that one, right? So if I just show you that, like, so we have this file here, and so just uh, I'll come to this one, right? Now in this file, actually, that this is the one causing us trouble actually, because here that we are doing that larger number of simulations, right? So that's why uh, it takes some time to refresh the page, right? So we will come to these applications later, right? So what we are discussing is the one that we discuss over here, right? So that you can see that we can calculate these probabilities here, and so that's what they're asking us to initially identify, right? So we'll the go into that one. So we can calculate the probability here, and then the cumulative distribution, the lower bound, right? And then the cumulative distribution upper bound, right? So we can identify them. So the probabilities, the now we have these frequencies, right? So now to get the probabilities, we can take their summation. So that's 400. So probabilities are the each one divide by 400, and I'll fix that one, right? So each cell is divided by the total. That's those are the probabilities, and I can pull it down, and then you can notice the probabilities there. And then of course the cumulative probabilities, lower bound is 0 here, and the upper bound is this one here, and then the lower bound will become the upper bound here, right? And then this is going to be equal to the uh, this one plus this one. Okay, and then the lower bound is always going to be this one, so therefore I can pull this one down, right? And then the upper bound will become the summation of that one, so I can pull that one down as well, right? So there you can see I have this the probabilities, lower bounds and the upper bounds, right? So we can use these basically the upper bounds, right? So therefore to calculate their simulations here, right? So if I go to here, and you can see, so now what we can do is like uh, we can calculate now here that we can simulate it for the several number of days here, right? So we can decide to go for a certain number of days here. So and so we want to calculate the average number of service idles, right, per minute, and the average number of the people waiting in the queue, right? So per minute, and considering the next the 20 minutes, right? And then they repeat the simulation for 500 times, right? And then We'll try to go for this number 4 later, right? So we'll uh, so we have these they calculate the average number of the serve idle and the idles per minute, and then average number of people waiting in the queue, right? So we'll calculate them. So uh, now we can use these two formulas here, right? So basically now we need to generate these random numbers here, right? So by for the 20 days, right? So they are considering the 20 minutes, right? So that's by considering for the 20 minutes, right? So therefore, uh, we can calculate that the I will take this here, right? So I can edit them. So this is the minute, right? Random number. So and these are the uh, so but when you compare to this one. Okay, right, sure. Now that is the number of customers, right? So this is the number of customers or number of arrivals. The You can define it as the number of arrivals, and then this is the uh, number of customers waiting, and then number of idles, right? So you can define them like that. The So we can go from say 1 to up to 20, right? And then I can generate the random numbers here. So I can generate the random numbers there, and then I can use this the command here. So the lookup function here. So so
So could you please show us the random function?
yeah, sure. The Give me a second. I will change this one, and then I will show that one. So I have to change this to 11. Right? So and this is not the G, right? So it has to be look up this number here, right? So okay, so yeah, this is the random number we can generate from rand command, right? The rand just equal and rand, and then the parenthesis, right? So then it will automatically generating random number between 0 and 1. right? So this is generating a random number between 0 and 1. And then I'm asking here to use this lookup function, right? So I'm asking them to look up this number here.
So
right?
can I interrupt, sir?
Yeah.
So when it comes to the random number you get and I get could be different.
Yeah. That's a random number. That's a different number, right?
All right. Okay. Thank you, sir.
Yeah. So every time when you run it, you're getting a new one, right? So you will see that like you're going to get different numbers every time, right? So that's why it is a random number, right? So you can say that that's totally random, and so we cannot predict that number, right? That's why we call it as a random number. Okay. So now in the lookup function, what they are saying is that, so look at this number here, right? And then check it with the the upper bounds here, right? So um, oh wait, yeah, this has to be the checking it in the upper bound here, right? So not from this one, right? So let me type it again here. So that is should coming from the E there, right? So in terms of the upper bound, so that is starting from E3, right? So E3 up to 11, right? So that's look at these numbers there, right? And in terms of the upper bound, if the random number is the above or the like if it is below this number, right? So that means so we are selecting that particular number of customers arrivals, right? So this is again from A3, right? So uh, I'm looking up these values there, right? And then if it is below that number and above the other number, so then it will fall under that one, right? So if it is above 975 and below 1, then it will fall under here. Yeah, so we are looking at that our random number. So first one is like say that now 459, right? So therefore that will go under the these two here, right? So therefore we are looking at this number here, right? So it is the looking up means that, so that the one that is above, right? So therefore we are looking at this number here, and therefore we are selecting number 3 there, right? So therefore this, for this random number, it has to be the number 3 that we are selecting as the number of arrivals, right? So let me run this and see. Yeah. So the so this is now the uh, so 0.67, that has to be number 4 actually, right? So give me a second. Is this the oh, okay. I was looking at the wrong column, right? So it's the not the upper bound column, but we are looking at the lower bound column, right? So this has to be not the E, right? So it is, has to be D, right? So that's why. And so this has to be D. They are looking at lower bound column, right? So then you can see that like 0.1, right? So in terms of low bound column, you can see 0.1 goes under these two. So then we look at this one, right? So that's how we get the 2, right? So, and then similarly, I can run this one for all these, right? So you can see that 0.97 goes to 7 there, right? So 95 goes to 7 there, right? So that goes under these two, right? So, and so on, right? So we can notice that we are looking at the the low bound here, and so make sure that we are looking at the low bound and then deciding the number of arrivals according to that. Okay, so we can go through this function there, lookup function, right? So you can have all these the numbers according to that, and then the in terms of the number of customers waiting and the number of the idle the servers, right? So that's number of idle servers, right? So we can identify them, right? So we know that initially, right? So now we can identify the capacity here, right? So that is the our the uh, the so it is the service rate that we have, right? So that's 4 customers per minute, right? So that's yeah, we are having that the they can serve the 4 customers per minute on average, right? So that is service rate, right? So we can identify that the so there are 4 customers, right? So so now if we have that like the 1 customer arriving at the beginning, right? So then the the number of customers waiting has to be 0 here, right? And then the number of idles will become the 4 minus 1, that is 3, right? So therefore, if this number is larger, right? So then the difference of those two, right? So will be the what appears here, right? And otherwise, the if this the difference is negative, then 0 has to be there, right? So therefore, I can have this one as the using the maximum function there, right? So the number of customers waiting has to be the maximum of difference between the uh, number of arrivals minus this one here, and that one has to be fixed, right? So I will fix this cell here or 0, right? So therefore, we can find out that, right? So we can see that it's become 5, then it is 1, right? And the opposite of this one here, it will become the maximum of the, so the idles will become the if the arrivals are smaller, right? So therefore, 4 minus 5, right? So therefore, that has to be in this one. I will fix that one minus this one here or 0, right? So maximum of those two. So you can see that. So if it is 4 there, then it is all both are 0, right? So just the we can calculate them all together. So you can see that number of arrivals and number of the customers waiting, right? So this is uh, the altogether what you have. So then in terms of these, we can calculate the averages, right? So we can calculate the averages there. So now you can notice that the in terms of these numbers, right? So what will be the average number of the customers waiting and then average number of idle servers, right? So this the two values you can get there, right? So then the question is asking, so that is what they're asking here in the part 2, right? So number of service idle and then average number of people waiting, right? So we considering that, and then we repeat what you have done 500 times, right? So we can like, sorry, 5,000 times, right? So we can write down that the any number of times there. So, but since that Excel is getting stuck, right? So I will use only 5,000 times there, right? So, so then I can do the simulation here. So you can see that on here in this example, the so we can do the simulation on each one of these, right? So we'll discuss about how we can get this one here. The so so we'll so we can have the simulation number and then the average number of customers waiting, and then idle service, right? So we can identify them. Let me just so so now of course now we can uh, run this one like for the down to 5,000 times, right? Or I can go into this one here. I think that is the wait. Yeah, this one here. So go to this filling here, right? And then series, right? So I need to fill the columns, right? And then the step value of 1 and then stop at 5,000. Wait. Why didn't it work? So it didn't work, right? So give me a second. Okay, sorry. So okay, so now it is there, right? So and then I can fill out that the averages there. That's the this one here. And this one here, right? So these two are the two averages, right? And then of course now I need to calculate that the simulate this one throughout that all these the numbers there, right? So mm, I think that we get it from here, right? So what if analysis, right? So yeah, data table, right? So we can go into that one, right? So that is the, so I will show you that again, right? So that is the coming from the data, right? So that's data and then what if analysis, right? So we can go into that one, right? So data and what if analysis, right? So, and then from there, the data table, right? So we want to go into those, right? So under the data, what if analysis, and then data table, right? So we can go there. Uh, the now for the uh, so we are using the columns here, right? So therefore, column input cell, I can say fix some blank cell there, right? So I just have to fill some blank cell there, right? And then just say that uh, mm, maybe I think I have to first set up this as a table, I think. Oh, no, wait. Mm, I think that is the, sorry, home. Wait, no, I don't need to. Oh, okay, I think I forgot. The, I don't need to label it as a table, so let me. I don't need it as a table actually. Okay, so I have to select this one actually. I so you not select the correct cell, I think. And in here, I have to select some empty cell here. Wait. It is not working. Mm, Let me start from here then. Actually, I'm not sure why it is not working. Think I used that what if analysis, right? Give me a second, I will search and see. Let me check. So, okay, I had to highlight this element. So I think I did not highlight it, right? So, oh, right. So, I'm not sure why it is not working. So, but it has to be the doing that too, actually. So, yeah, so repeating this one, right? So that has to be done in that order, right? So that's the uh, so that is these are the steps actually you should follow, right? So that's uh, I will check and see, right? So something uh, I cannot identify why it is not working. So usually it should work in that way, right? So yeah, that is the what I'm doing actually, but it's not working. Yeah, something went wrong in Excel actually. I'll check in and see. I, I cannot identify right now. So I will inform you, right? Um, so, but that's how you can work on it, right? Uh, you can see that like maybe like uh, in this computer, I think since I'm having this simulations here, so all these are kind of like so you're getting this command here, and so that's coming from that simulation, and then once you have them, you can finally take the average of those cells there, right? So that will give you the average, the number of the values you can have. And then of course now finally like what I does you do give to the so what advice you can give to the increase the service rate up to the 5 customers per minute. So you can think of like so what are the advice you can give. So now the in terms of the average number of customers, the waiting, and then average number of customers idle, right? Average number of servers idle, right? So by looking at these numbers, so now what can you identify here? So now the we have a service rate of 4, right? So therefore, uh, so to increase the service rate up to 5, right? So what can you say? So of course now that is like the kind of like general you can answer there, right? So the to increase the service rate up to 5. So what can you think about the improving here? Mm, The in terms of like increasing the service rate. So especially now when you're thinking about these the services providing like this, especially now when if you're planning to increase the service rate, the best thing you can give is the uh, you can increase the number of servers there, right? So that's if there are like 2 people working, then you can increase that to 3 or 4. And if there are like the you can increase that whatever the number of counters there. So that way easily you can increase the service rate. And once you increase the service rate, definitely we'll see that number of customers waiting will go down, right? And then number of idle servers will increase, right? So it depends, right? So now in this case, the now we have the number of the values are like that, right? So if I refresh this one, I think there is F9, right? Yeah, once you press the F9, so it's refreshing, right? So this goes to 0.85 and 0.75, right? So these numbers, you can see that they're changing, right? So in this case, of course, now the number of waiting customers are not that much, right? So 0.15 and so on, right? So in this case, of course, it seems like we don't need to increase that number of the servers up to 5, right? So that's number of service rate is 4 is enough in this case, I think, right? But in general, if you want to increase that, then definitely you have to increase the number of uh, the number of servers there, right? So that's how you can work on this example. I will provide you that the answer here, right? So and so then like now the addition to that one, right? So we discuss about these examples here, right? So that's kind of like the uh, we are in terms of modeling the queuing system, right? So that's now previously we did not directly worry about the queue there, right? So we just simulate the waiting customers and see that like the average queue from there, right? But in general, once you think about like the customers arriving and the departure, right? So therefore, you can define the queue in this way as well, right? So there you can see you can simulate this one for maybe like 100 or 200 times, right? And then you can calculate the average waiting times as well. So there you can see I discuss about that. So in at the beginning, that nurse service time is fixed, right? But even you can change that one as well, and then waiting time in the doctor, and then waiting time in the system altogether, right? So we can calculate them, right? So there you can see each one. We have a probability distribution. So based on that distribution, we are calculating that our the random numbers and the arrivals. So that same function we are using. Based on the service time, right? So the we are using that the all these service times, and then the in the interarrival times, right? So that's we are calculating them using the functions there, right? So the same lookup function, right? So that's we are using that one, and then of course using the interarrival time. So we start the arrival time, and then the uh, basically adding up the interarrival times, right? So that's our arrival time, right? And then the starting time we can decide by the interarrival time, and then the maximum of the finishing time and the interarrival time out of these two, right? So then we can find the second random number and the service time at the nurse, and then the finish time based on the service time at the nurse, right? And then the waiting time you can calculate based on the difference between the finish time, right? The the E9 and D9, right? So that is the waiting time is the difference between the arrival time and the start time, right? So sometimes if the so you can see that like in this you can say the arrival time and the start time has a difference, right? So therefore that is the waiting time we can find out, right? And then the uh, same thing you can do for the doctor, and then time in the system you can calculate from the original start time and the finish time. So difference between those two will become the time in the system. So we can calculate, so either I can give you like something like this or some calculation like this one, right? So those are the things, and then like finally I can go into this one here. The, yeah, the clustering example, right? So I have these variables there. So I can go with that the VLOOKUP function. So that's previously we go for the lookup function, right? So this is the VLOOKUP function, right? And I'm looking at this observation, and then my the variables here, right? So I'm looking at this table, right? And then second column, and then the I don't need any accumulate in here, right? So therefore I put that as false, right? So I can look at that the VLOOKUP function for the entire row there. So then of course now I'm taking that the first observation and second and third one as my initial cluster, right? So therefore you can see these three there. And then later on, I'm using the different one, right? So these are the average function. So here that like you can see when we can that go for the VLOOKUP, we can just copy and paste them as well, right? Here that I'm using the average if function, and then the in terms of clustering here, right? So I can take the square root of the differences, right? With the values here. The first one minus this one, second one minus this one, and so on, right? So you can see that the first observation, so therefore everything is 0, right? So therefore it is 0. And then this is the cluster 2, that is the second observation. So therefore there is 0. Cluster 3, that is the third observation. So that is 0, right? So you can see that. And the others, you can see the distances. And then you can see the cluster number here by using the match function. So matching it with the minimum, right? And then the cells J 10 to 10, right? So that's these cells here, and so find the minimum out of them, and then match with the cluster ID, and so we are putting the cluster ID here, right? So the so that is the match function we are using. The And once you put the cluster ID there, then this you can use that cluster number here for the average if function there, right? So the average if the so yeah, so this the I'm looking at this is the cell here, right? Or one and these are three, right? So this the third one, fourth, and fifth one, right? So look at this number, and then if the cluster number is equal to that one, then average the table one, variable two, and so on, right? So I'm averaging them each one like that. And based on new clusters here, I can calculate the distances, same as before. And again, I can do the cluster numbering there. So I can repeat this one several times. And later on, we will see that these centers are not going to change that much, right? So if the centers are not changing that much, that indicates we are basically find out um, the converging to certain numbers there, so we can fix to those numbers, right? So but now for the exam, I'm going to ask you like calculate the 2 or 3 iterations. So usually you have to do this for say maybe like 10 or 20 iterations, right? So then you will see that. Okay, so that's the idea of that. These calculations, so that's the basically like the things that we discuss. So we talk about this one as well. I will provide you this answer as well, right? So uh, I did not calculate this answer. I will calculate this one as well. So basically now I have the answers for all these. So I'll put those, I'll give you the answers for them as well. Uh, and here also I will find out why it is not working on this one. So I think that's it, right? Any questions so far? So it is 9:45, right? So uh, hope this is okay. So and feel free to ask me any questions if you have, right? So we can go through that the all these calculations. So do you know that when you have the exam? when when is your exam?
March 28th.
March 28. Okay, so you have a little bit time, right? So you can study, but you have other classes, right? So exam is starting on 15th, right? You said earlier, I think, yeah. So we have the other classes as well. So now, in terms of like here, you can see that there are a lot of formulas, right? So I will not ask you to remember all those formulas, right? I will provide you the formulas. So some Excel functions that you have to remember, right? So I cannot give you those actually, right? So all these Excel functions that we are using, you have to remember them, right? But any other formulas, I will provide you them. Okay, so I will uh, prepare the exam like that, right? So you just have to memorize what you do in Excel. Okay. So other than that, anything else? So if not, then I will. Uh, so shall we end up the lecture then? Okay. Right. So since you don't have any other questions, I will finish up the lecture then, right? See you guys then. Like all the best. Like so, the so we may not meet again, right? So that so all the best for you guys, right? So if you need any help, contact me.